and do the same thing with this question, and we'll use the computer to do it. One other thing I'm going to do here is just make it so that SymPy will print pretty all the time. And this init printing will do that. So, okay, now the other thing to note here is our function, since it has a cosine in it, I have to be careful. And if I'm working symbolically, I have to use SymPy to define that cosine. Again, I want to make sure that x is a symbol. And then we can find the first derivative. Okay. Then we can just use that. The critical point, again, we'll have an equation, and it's just an equation, and I'll say that's the derivative of f of x with respect to x. When does that equal 0? And it's at pi over 2. All right. So now the other thing that we want to do is, this is our critical point. So with the second derivative test, we just need to plug that into the second derivative. Well, to find the second derivative in SymPy is actually quite nice. We just say f of x with respect to x, and then we can enter, if we want a higher order derivative, like the second derivative, here we go. It's negative cosine of x. And if we evaluate that at the critical value, all right, what is, psi dot cos of psi dot pi over 2, that's 0. So inconclusive. So now maybe if let's go ahead and look at this again. Return x plus and p dot cosine of x, and we'll define x to be numbers now. And we'll go from pi over 2, that's like 1.5, so we want to make sure that we get that. And we'll plot it. And we'll also plot that point. Right? np dot pi over 2 and f of np dot pi over 2. Make it a circle. Okay, and as we expect, now again, with the second derivative test, 0 gave us that inconclusive, whereas prior, our first derivative test, it was increasing before and increasing after. Both ways we get that it's not, well, in this case, I would say that I can't tell, so it's not always conclusive. All right, sometimes it's easier, but sometimes it doesn't provide us with a clear answer as to whether or not that's a maximum or a minimum. Another example would be in our earlier functions, we looked at f of x equals x to the 4th plus 3x squared or something like that. If we just had y equals x to the 4th, we know that that thing looks like this and has a minimum at 0, but the second derivative is going to be, well, 4x cubed, and then so we get 12x squared. Right, that would be the second derivative. And if we evaluate that at 0, which is a critical point, we get 0. So the second derivative test is inconclusive if y equals x to the 4th. Okay, so it's not always, doesn't always give us answers, but can sometimes be a much more efficient way of finding whether or not a point is a maximum or a minimum.